This video is sponsored by PCBWay. Stick around to find out how they can be your one-stop shop for custom PCB fabrication and professional 3D printing.
So a model like this is fairly complicated. It's not something you could just whip up, send to your printer, and be done with in an hour. This project is roughly a weekend project, and when it's finalized and done, you need to have a 600mm build volume printer in order to print it out in one single piece. Now, I could, if I wanted, use calipers and just measure the entire model that this thing sits in, although that would be a little bit difficult. So instead, we're going to be using the Revopoint RANGE 2. Now, I've used quite a few Revopoint scanners. I have a few videos on the channel, and I really do love the Revopoint lineup. There are things that could be better about them, but for the price, these things are incredible and they offer a lot of functionality. For this particular project, the RANGE 2, like I said, wasn't really required. However, it definitely gave me confidence to print out these large panels and components to test the model. Seeing as some of these test prints are over an hour or 2 hours long, I wanted to make sure I had the best possible fit before I sent it off to the printer. But before I tell you how I completed this project, let me give you a little background information on what this project actually is. So back in the 60s or 70s or somewhere in that time frame in Japan, they had these machines called Pachinko machines. Now, gambling in Japan was illegal, so Pachinko machines were a way around that. In Japan, you would have a building called a Pachinko parlor, and a Pachinko parlor would be essentially the same thing as a casino, except there would be hundreds of Pachinko machines rather than slot machines. So Pachinko machines operated on these little metal balls. Now these metal balls that I have are roughly, oh, it's in inches, hold on. Roughly 11mm. Of course, we're upside down here. Now, these are essentially little ball bearings, and a Pachinko machine is an entirely mechanical device. You load these ball bearings up, you pull a lever, and then you release the lever. It's spring operated. It shoots a Pachinko ball through the machine. I'm looking online at what you can relate a Pachinko machine to, but I can't come up with what it is. Essentially, a Pachinko machine has a bunch of nails hammered into it, and when this ball goes through the machine, it bounces off different nails and it essentially falls through a path. You're trying to get this ball in a certain hole. And I can't think of what those games are called, but essentially it's like one of those games where you have a disc at the very top and then you find out where you want to drop the disc. You drop the disc and it bounces off a bunch of nails, and at the bottom there's a bunch of prize categories. Wherever your disc lands is the prize you've won. Anyway, on screen somewhere around now, there should have been B-roll of what a Pachinko machine is, so you should understand what I'm talking about. So anyway, that's what a Pachinko machine is, but how did it replace or suffice for gambling? So this is where it's all genius, and that's because these balls have a value attached to them, and I don't know what that value is exactly. However, you basically purchase these balls and then you load your balls into the Pachinko machine, and then you play the Pachinko machine with your own balls. In the Pachinko machine, if you land a ball in a hole, it hits a jackpot, and then balls that you did not purchase will come out of the machine and into your stockpile. Then, whenever you're done gambling or done playing the Pachinko machine, you'll take all of the balls that you won and you'll go back to the Pachinko parlor and you'll sell the balls. Essentially, you're doing the same thing you would do at a casino when you're playing Texas Hold'em. You'll go buy chips, you'll play Texas Hold'em, and then when you're done, you'll take your chips and you'll sell them back to the casino. Now, the real way that they actually got around this is because essentially you would have one building across the street from the Pachinko parlor, which is where you would purchase the balls. You would then walk across the street, you would play with your balls at the Pachinko parlor, and then when your night is done, you would walk back across the street to where you purchased the balls, presumably owned by the same person, and you would sell your balls back. And so that's how the old ancient times you would gamble in Japan. So anyway, that is a really cool story, and I have been infatuated with pachinko machines ever since I got this one that I have. How I got it is kind of another wild ride in and of itself, but I've been absolutely fascinated with these things ever since, and I love playing the machine that I have. It's a really hard game to play. It's a losing machine for sure, but it's incredible. The only downside is that when you play the game, the balls drop out of the back of the machine and they fall into an empty abyss, which is where this comes into play. Now, this is, like I already mentioned, roughly 600 millimeters. And if I were to be measuring 600 millimeters with one of these, well, for one, this is a little too small, so it wouldn't work. I would have to resort to a tape measure, but even so, it would be incredibly difficult, and that's why I opted to use the Revopoint RANGE 2, because what I really wanted to do was scan the back of the pachinko machine, which is where this fits in, and then I wanted to import that into Fusion 360 and then build my mock and my SketchUp in Fusion 360 without having to measure anything. So for the most part, it was actually fairly successful. See, the Revopoint RANGE, it has kind of like this jaw clamper thing here. It allows me to put my phone into the little holder, if you will, and I can actually use the range itself to scan directly to my cell phone. That's gonna allow me to essentially go wireless with the phone and the scanner. Well, actually, of course, I've got this in there backwards, but you get the idea. That allows me to go wireless with the scanner and the phone, so that I don't have to be lugging around an entire computer as I'm doing the 3D scanning. That is actually, honestly, one of my favorite features about the Revopoint lineup, and that's not unique to just the range. As I mentioned before, I've had a few other scanners from the Revopoint lineup. I have the Mini and the Pop 2. I used to have the Range 1, and actually why I chose to get the Range 2 is because the Range itself was my favorite of the bunch, and so I figured the 2 was simply just going to be better. And throughout this series of Revopoint scanners that I've had, the software and the firmware on all of these scanners has been getting progressively better and better. It's honestly to the point where you can load up one of these scanners onto your phone, download Revopoint Scan 5 or whatever it's called, the app on your phone, and within 5 minutes, I'm serious, like not joking, within 5 minutes of getting the scanner out of the box, you can be scanning and have a full model scanned. Without me fanboying about Revopoint so much, they really genuinely are a good-hearted company. They have your best interest at heart as a consumer. They've been upgrading scanners, and while yes, they do create a new scanner fairly regularly, your old scanners don't become obsolete. They still get firmware upgrades, and it's regular. They still upgrade whenever the software on the computer or the software on the phone app upgrade. So again, they're not obsolete, and they continue to get better and better. So anyway, the reason that I chose the Range 2 for this particular project is because the pachinko machine is fairly large. It's somewhere in the vicinity of 600 millimeters. 600 millimeters, that would be huge if it was 600 meters. But so I chose to use the Range 2. Now you could use the Revopoint Pop series, although Range just seemed to be better. It's designed for larger objects. And one more thing about being able to hook it up to the phone, the reason why I really like that so much is because if I didn't have the phone to hook it up to, I would have to hook it up to the laptop. This laptop is probably in the vicinity of 10 pounds, 5 pounds, 6, I don't know, I'm not really good at measuring weight. This thing's chunky, this is really heavy. This has a 2080 in it. It's really thick. And if I need to provide power to this thing, the power brick is the size of my face. So being able to scan directly to the phone is a huge win. Now finally on to my design philosophy here. As you can see, I went through all the stages of stress, even though I still used a scanner. And if I didn't have a scanner for this project, it would have been even worse. So let me try and organize everything to kind of show you what I did. and I don't think this is going to be in order. I don't think there's any possible way I can explain this fully in order. So you see, I've got some pieces that have these this kind of profile like this, and then this one has a profile on this side that's curved. This was one of the final designs, so we'll get to this at the end. And then here we go. So I've got this piece. This is just a straight U channel. This was one of the early designs, and I thought this was a great design. This was good because when the ball drops out of the machine, it kind of drops into this cavity, and actually there's a ramp over here. There's a high point here and a low point here. So you can see when I drop a ball here on this side, it falls out the other side because of the ramp. That's kind of smart. Basically, the ramp goes into one of these bad boys, and one of these bad boys has a ramp here. So the ball falls and it kind of rolls down this whole channel. Watch. So, oh, you can't, well, oh, fell out the bottom there. So anyway, you kind of get the idea there. But this didn't work because these metal balls, when they drop, well, you could see what happened. It kind of bounces out. So that's why these, not good. That's when, let's see here, that's when I decided to start to design them with this channel. So now we have, we have this little, whatever this thing is. Basically, the goal was when this ball bounces, it will kind of hit this back channel here, and if it does, it will roll back in. I'm not really sure if you're seeing, but essentially, if it does hit this, this is angled. I want it to just roll back into the U channel, but problem with that was sometimes the ball would still bounce over this part, so I had to extend the length of this. So this one, no good. Now, one of these, oh yeah, here we go. So many designs. You see how we then eventually, let's see, how can I even show this? This is hard to see on camera. So this part is taller than this part. Well, eventually the ball started to hop out the other side, so I had to make this part taller because it wasn't, this wasn't tall enough, so I basically took this and extended the height of it. Anyway, so more designs. They weren't good either. That leads us to this part. Here we go, where I've extended this part and raised this part. This was almost where it needed to be, except it still wasn't good. The ball was still hopping over this whole channel. I'm not really sure how, but the ball's very bouncy. So, on to one of the final stages of the design. Basically, we have a very tall ridge here, and this actually curves. So when the ball bounces in here, it'll hit the top of this curve, and then it'll kind of bounce back down into it. So after lots of testing, this is kind of the final design and shape that I came across that worked very well. And so it was almost the final design. Actually, I think it was the final design, so yeah. Looking over here at the final prototype, or the final design, not the final prototype, the final design, looks like this was the final. So anyway, there you go. So these were good, but I'm still gonna throw them for kind of the fun. Oh, it broke. Nice. And this is why, hold on. This is why I didn't print it in plastic. All right, so next we need to talk about this. This thing was an absolute menace to print or design. Well, print too, but this was a menace to design because I finally, for the first time, used 3D sketching in Fusion 360. Now, This video is not going to be a full tutorial on 3D sketching. In fact, it's not going to be a tutorial on 3D sketching at all. But in Fusion 360, there's a checkbox that allows you to go into 3D mode as you're sketching. It's very confusing, but it is incredibly convenient. It was very, very useful. Essentially, when you open up a sketch in Fusion 360, over in your right panel on your sketch palette, I'm looking at the computer right now. On your sketch palette, you have a checkbox that says 3D sketch. If you click that, it does something on the inside and it allows you to spin that little XYZ globe in the top right corner, and it allows you to sketch in 3 dimensions. Now it's very, very confusing and it's going to hurt your brain, but it's very powerful. Essentially what I was able to do was, in that 3D sketch, I was able to take a point here at the top of the ramp, and then I kind of took a point angled down a little bit over here, and then I rotated the globe. So if you followed along with anything in this video, which you probably haven't really been able to do, and that's fine, but if you have followed along with anything in this video, I somehow came up with this massive design, and then, well, I didn't want to print this whole thing at once for 2 reasons. One, because I don't actually have a printer big enough to print this whole thing, and I wanted it in one piece. And 2, well, if I did, this would be a multi-day print, probably like 2 or 3 days, and, well, you saw how many failures I had, so I designed the whole thing, and then I chopped it into small bits. 4 bits to be precise, 1 bit here, 1 bit here, 1 bit here, and then 1 bit here. And then I printed them one by one just to test to make sure that they worked. And when I was finally done testing all of those pieces, which of course took a very long time, I then had this whole piece shipped out to PCBWay because I wanted PCBWay to print this entire thing in resin, because, well, A, I don't want it to look 3D printed, and resin prints are kind of very professional looking. And 2, well, again, I didn't have a printer that could print the whole stinking thing. This is huge! This is massive! So, well, it got sent off to PCBWay. It arrived at my house within 4 or 5 or 6 days. I honestly don't remember. And unboxed it, unpackaged it, I stuck it on the Pachinko machine, and what do you know? It fit. Well, that was expected because I did all that testing. So I'm not really sure what the major takeaways of this video are, because honestly, I had a completely different video planned. The problem is I recorded that video and absolutely no audio was saved, so I've kind of improvised with this video. I think some of the key takeaways are that a lot of people are going to recommend that you always use calipers, and I did use calipers for this project, but the primary tool that I used was not calipers. The primary tool that I used was the 3D scanner, and while Revopoint did send this scanner out to me for free, and I really do love their products, I actually think the 3D scanner was the right tool for the job. As I've already mentioned, this is my caliper. It maxes out at 156 millimeters. I mean, look at this. I would have to, like, it's not big enough. It's just not big enough, and like, how? The scanner allowed me to scan the entire Pachinko machine. This way I don't have to use calipers or a measuring tape or something that's less precise. Once I have that model, I can import the entire model into Fusion 360, and I can do the actual sketching of this design directly on the actual Pachinko machine. Once I had some of the rudimentary sketches on the Pachinko machine within Fusion 360, I could then go through with the calipers and take any small measurements that I needed. But having the actual model imported into Fusion was incredibly useful, and I genuinely don't know how to portray that to you in any other way. Another key takeaway from this video is that I highly recommend you keep people like PCBWay in your back pocket for when you need a project to be printed. It might be very easy for you to say, oh, I don't need PCBWay as a service because I have 3D printers myself and I can print these things for myself. But there actually, in my opinion, are plenty of reasons why you, someone that owns a 3D printer, might want to use a service like PCBWay. One, the same reason in this video, if you want to print something that is absolutely massive, you're probably not going to have the ability to do it yourself. Now, I know there are some FDM machines these days that get up to 500 millimeters cubed, or if you have an Orange Storm Giga, you could do a meter cubed, and I could have easily printed this on an Orange Storm Giga. But most people don't have a printer that big still, and also, I wanted this printed in resin. Now, I have absolutely no idea which printer PCBWay used to print this thing, although I could absolutely guarantee that it would be so far and away outside of any consumer's budget to own, because obviously whatever printed this monstrosity was a commercial grade resin printer. Some other reasons why someone like you might want to use PCBWay is if you have a particular project that is, I don't know, say 30, 40, 50 pieces big, maybe you only have 1 or 2 printers and you don't want to print it all yourself. You could simply send those pieces off to PCBWay, go to sleep for 3 or 4 or 5 nights, and then go to your mailbox the next day and you've got all 50 pieces in a box. You didn't have to worry about printing it. You didn't have to worry about print failures. They just showed up at your house. I've used PCBWay's service for quite a few things, from printing very large resin models, to printing metal models, to printing materials that I didn't have the ability to print. And every single time I've used the service, my parts have arrived fast and they've been of the highest quality. If you haven't yet tried out PCBWay's service, I highly recommend you give it a go. And I've got a link in the description if you want to learn more. This really was kind of just a weekend project for me, but I still have more that I need to do. This Pachinko machine has more projects. There's more things I need to design. I need to design a ball catch. This way, when the balls spill out the front, they don't just fall onto the floor. So there are other projects with this machine, but this particular piece was so advanced and so fun. I used cool tools like the Revopoint RANGE 2. I thought you guys might want to follow along for the project. Now, I really have no idea how this video is going to turn out because this was a totally random, off-the-wall, very spontaneous recording. Like I said, I lost audio from my original video, but if you guys like this video, let me know in the comments section down below. Do make sure to leave a like and a subscription. I'll have more project videos like this. I'm really working on getting more into the project scene and not just reviews. So if you like this, like I said, do be sure to let me know in the comment section down below. Otherwise, I will see you guys in the next video.